Hello, good evening all. I see a message in the chat. Uh, so is the maths session also going on currently?
Yes, sir. Yes, ma'am.
Ma'am, the TA session is going on for maths.
Oh, TA session is going on. Okay. That is all right. No issues. Yeah. Okay. So we'll start then. Let's wait for a couple of more minutes and then we will start with the session. So today we'll be doing week 3. So we'll go through all the concept that has been done in the lectures, and later on we'll look at the problems in the next session.
Excuse me, ma'am.
Yes.
Ma'am, in the meanwhile, could I ask the question related to ordinal data and interval ratio data?
Yeah, sure.
Ma'am, volume will be considered ratio scale of measurement or interval scale of measurement?
Volume as in like what? Can you tell me can you give me some numbers?
Volume like 2 meter cube, 4 meter cube, and 5 meter cube.
Volume as 4 meter cube.
Yes, ma'am.
Is volume being measured in meter cube? No, right? I mean,
Ma'am, volume means we are
okay.
multiplying length.
Volume as in like okay. Okay. So volume will be like you will be doing so okay. So it will be some numbers, right? I mean, you will have let's say one meter cube, 2 meter cube, as you said, right?
Yes, ma'am.
There it will be ratio scale, right? I mean, you can perform all the operations.
And ma'am, but ma'am, here zero also exists, we can say, no?
Yes. I mean,
And
there
ma'am,
is an absolute zero. Yes.
and for the class strength, number of students in a class, it will be an interval scale or ratio scale?
Number of students in the class. I mean, depends what do you want to do from that data, right? I mean, like when you write number of students in a class, I mean, what exactly are you looking for? That also is important to look into.
So can we consider class strength as an interval scale of measurement?
Class strength as interval scale of measurement. So when you talk about class strength, it means you are saying a class of 20, a class of...
Hello, ma'am, you are not audible.
I'm not audible?
Ma'am, your audible might be network issue at the other end.
Okay. No, when you say class strength, so basically talking about the class size, right? Whether it's a class of 1 or class of 10, 20, basically that.
Yes, ma'am.
Yeah. So
Ma'am, can I ask a question?
okay, let's not we are doing week 3 today, so let's not so that was like we were starting the session, so I I took the question, but
No, ma'am, but week 1.
Sorry.
Just a simple question.
It's okay. You can ask me later, or you put it in the
Ma'am,
chat box.
ma'am, can you explain what is the time series data and cross-sectional data?
Okay,
I'm
so all this,
totally confused.
yeah. So okay, all this we have already discussed in great detail in week 1, right? So today let's look at week 3 first, and then if you have any doubt, you can ask me. Okay.
Okay.
Let's look at week 3 because all this you can go back. All the sessions are live streamed. You can go back, look at what all these definitions are, when what
Okay.
exactly is everything, right? So these sessions are already available. So let's focus on week 3 today.
Okay, ma'am.
Okay. All right. So we'll start with week 3, and okay. So before we move to the topics of week 3, what all we have seen so far, right? So we have seen, we started with what is statistics. Then we talked about the um, two different kinds of statistics. One is descriptive and there is inferential. And when we talked about inferential, we also talked about the sample and the population, right? And then we looked at the data collection part. So how do you collect the data? I mean, what all, when you have the data set, what all you have something called variables, you have something called cases, right? All this we have looked into. Then we have data types, and the data types will be like either data is categorical or whether data is numerical. So if it is categorical, like what all scales of measurement can you perform? When it is numerical, you divide it further into two parts. One is discrete, other is continuous, right? And then we also looked at cross-sectional and time series data and the scales of measurement. Then at last, we looked at how do you describe the data. So when we say, I mean, you have the data set given to you, and now like given the data set, what all interpretations can you make from it, and like how do you basically describe whatever is given the data set, how do you describe it? So one way we looked at is to create the frequency table and then looked at relative frequency. Then how do you then we also looked at what is a bar chart, what is a pie chart, when do we go for a bar chart, and when do we go for a pie chart. Then various different techniques in which the graphs or the statistics can lie. So we also looked at truncated, we looked at violations of area principles and so on, and what to do in such cases, right? So all that we have looked into. Then we also talked about the two different central tendencies of a categorical data, which is the mode and the median. Because on the categorical data, we could only perform two different central tendency, and that was mode and median. But now when you have, now moving to week 3, we'll have the numerical data, right? So if you have numerical data, there are various things that you can perform. So let's move to the numerical data. So today we'll look at the numerical data. So again, when you have numerical data, you have you can differentiate. I mean, you can either categorize the data as continuous or in discrete. So discrete, when we call a data as discrete, when you are interested in counting something, so that kind of variable is called discrete. Whereas whenever you are trying to measure something and the data set, if it can take any values in the range, then such kind of data you put it in the continuous. Then how do you, like when you are dealing with the categorical data, right? When you had categorical data and you had to plot the frequency tables, right? So what you did in frequency table, so let's say you had different categories, let's say A, B, A, C, D, B, A, C, D, and so on, right? So in this case, we had the categories A, B, C, and D. And these are not numerical, they are just categories. And when we had to make a frequency table, we looked at how many times each of these categories have occurred in the data set, right? So in this data set, category A had occurred 1, 2, 3, 4 times. Category B has occurred 2 times. Category C has occurred 2 times. And category D has occurred 2 times. So similarly, this is what we did for, whenever we were looking at the frequency table, this is what we did for the categorical data. But when we have the numerical data, how do we make the frequency table, right? So one way to do it is like, if let's say if you have a small data set, if your data size is quite small, like let's say, even though it's numerical, if I'm saying I have a small data set of some numbers, let's say 1, 2, 3, 4, 1, 5, 9, 8, and something, let's say it's some 10 numbers you have. Okay, then if you have to make the, so one way to look at the frequency table is you group the observations into classes. Okay, so we're talking about frequency table here. So the first thing is you group the observations into classes. And when you group these observations into classes, then saying that you have the observation and you're grouping it into classes, it means you are putting this data set into, let's say, small bins, right? You are creating different bins, and you and whichever bin your data set or your observation falls into, you put it into that and you say this is one class. But in case your data set is quite small, then in that case, in case of small data set, you consider each of the observation as one class. You treat each observation as one class. So when we say you treat each observation as one class, as in like you're no longer, let's say in this case, my observation is 1. Again, you have observation 1, 2, 3, 4, 5, 8, 9, 10. So each of these observations, they are saying this is class 1, this is class 2, this is class 3, class 4, class 5, and so on, right? Each of these observations, you consider it as one class. This is what we do when you have a smaller data set. But when you have a larger data set, when your data set is quite big, then treating each observation as one class is not a good idea. Then in that case, you actually make some classes, like you do, let's say, your data set lie between your data set takes the value between 0 to 100, let's say. Okay, so you put let's say then in that case, let's say you divide your observation into 10 bins, into 10 classes, and each classes will have a size 10 each, right? So this is one way to do it. This is one way to differentiate your data. One way to like put the data set, like in case the data set is quite large, then you put that into different classes. And once you have once you know the classes, you find the frequency table. Like if I say in the interval 0 to 10, okay, so my data set constitute of let's say values from 0 to 100, okay, and you have a large data set. then what you do is you look at each of this data set and you see which class it falls into, which bin it falls into. So you put that into that bin, right? And then in each bin, let's say 0 to 10, we got some two data, 2 points, 2 observation. Let's say in 10 to 20, we got some 10 observations. So accordingly, you make the bars. Did somebody say something in between?
No, ma'am.
Okay. So this is what you do when you have a larger data set, right? So once you can put it into different classes, you can find the frequency table, and then you can also find the relative frequency, right? Okay. So for example, so let's take one example. So let's say the example is you have 2, 1, 3, 4, 5, 2, 3, 3, 3, 4, 4, 1, 2, 3, 4. Okay. So can you tell me how many classes will I make for this?
5.
5.
5.
5 classes.
So I have 1, 2,
3, 4,
3,
5.
4, 5. Now I need to look at, so see, this is not a very large data set. This is a very small data set and it has a very limited value. It takes the values only 1, 2, 3, 4, and 5. So there is no need to put it in different classes. So in this case, classes will act like each of these distinct observations. So we can say this is our class 1. This is our class 2, and so on, because this is not a very big, large data set. So now we need to look at how many times 1 has occurred in the data set. So that will be called as frequency, right? So that will be called as frequency. Then you can also find the relative frequency, right? So how many times 1 has occurred? It is 2 times, right?
Yeah.
How many times 2 has occurred? So 1, 2, 3 times.
3 times.
3 has occurred 1, 2, 3, 4,
5 times.
5 times. 4 has occurred 1, 2, 3, 4 times.
4 times.
And 5 has occurred one time only.
One.
So how many total number of observations are there?
15.
15. Yes.
18, no?
18, 3, 4, 5, 10, 15.
Ma'am, it's 15.
And what is the relative frequency? Like, let's say if I want to find the relative frequency for 2.
Frequency
2
upon
by
2.
15.
2 by 15.
So
2 by
2
15.
by 15, 3 by 15, it should be 5 by 15, 4 by 15, and 1 by 15. And all this should add up to 1, right? Which is adding up to 1. So whenever you make a frequency table and you find the relative frequency, so always check if it all sums up to 1. Okay. So even when you're
And this-
solving, yeah,
Ma'am, this is discrete data, na?
this is discrete data. Yes. Now, this was the example for the discrete data. Now, what happens when you have continuous data? So, okay, we will not take a very large data set. We look at comparatively smaller data set, but it because we are just trying to solve the problems here. But in real life, your data may not look like that, right? You will get a very a large number of values. So we cannot do it manually here. You can use the Excel and so on. But when you have a large data set, so in that case, there are few things that you need to look into. So the first thing is you decide the number of classes. So how many classes you want? Then, so generally, when we talk about the number of classes, we ideally go for some 5 to 20 classes. This much is acceptable. Okay. But we generally try to stick till 10. Then the second thing is each of the observation should belong to only one class. So it shouldn't be like you have taken one observation and you say this observation belongs to this class also and this class also. This cannot happen. So if you are picking one observation from the data set, you can either put that data set in this bin or you put this data set into that bin. It cannot be both, right? So this also you should take care of. So this is what it says. Each of the observation should belong to
Only one class.
belong to only one class. Right. Then the third thing is we generally choose the class intervals of equal length. Choose the class intervals of equal length. This is just for like this is much easier to work with, so that is why we choose class interval of equal length. So whenever you whenever you see you have a very large data set, you should first decide how many classes do you want, and you should take care that all the observation that you have that should fall in some of the classes, and none of the observations should go to more than one class, right? And you should also this is not this is not a strict condition, but you should try to choose the class interval of equal length. Then when you talk about the class, so there are few terminologies that you are going to look into. So there is something called the lower class limit. Then you have upper class limit. Then you have something called the class width. Then you have class mark. And you have class interval. Okay. So suppose you have a class 0 to 10. Okay, this is one class we are talking about. So what we call as, what do we understand as lower class limit? So the smallest value that will go in this class 0 to 10, that will be called as the lower class limit. And the largest value that will go in a class will be called as the upper class limit. So lower class limit is
0.
Smallest value that
in this case, yes.
In a given interval.
Yeah, smallest value that could go in a class. And upper class limit will be the largest value that go in a class. Then when we talk about class width, it is just the difference between the upper class limit minus the lower class limit.
And the difference of two lower class limit.
Sorry.
Class width. The difference of two lower class limit.
So it is more like, okay, so let's not write this. You can also say that So let's say you have here one class and you have another class, right? So our standard way to write it is, so whenever you are given a class, right? So each of this class will contain the lower most value. The class interval will contain the lower end value, but this will not be contained. So it will more like the open interval. So let's say if I give you a class of class which the first class as 10 to 20, and then you have 20 to 30. Okay, so this first class 10 to 20 will contain the values will contain the value 10.
But voice is
Sorry.
not clear.
I think it is clear. I am not able to hear you properly.
At the
Yeah. Okay. So when you have when we write, okay, so I have written two classes over here, right? So I have written 10, 20, and I have written 20, 30. So when we talk about 10, 20, so in this class, in this particular class, the maximum value, the minimum value that an observation can take is 10. I mean, if
10.
if you have a set of observation, and if it has 10, and if your observations has 10 in it, then it will lie in this interval. But if your observation has value 20, like let's say you have a data set where you have, let's say, 5, not 5, because we are giving just 10 to 30. So let's say 11, 10, 19, 18, 15, 10, 12, 20. Okay, so if you have 11, you can put it into this class, right? You can put it in 11 into this class. If you have 10, you can put it into this class. If you have 19, you can put it into this class. 18 can be put into this class. 15, 10, 12. But look at 20. This 20 cannot be put into this class. It cannot be put in this class. This 20 you will have to put over here, because when you take this class, it will only it should only contain this class will contain the value 10, but it will not contain the right end value. So in this class 20 cannot happen, 20 cannot occur. So you will have to put 20 into the different class.
So ma'am, then what is the upper class limit for this?
Upper class limit is 20 only, because we're talking about continuous data now, right? So this open interval, close interval, all this, more or less it is treated as the same in this case. So if I say 10, 20, and if I say 10, 20, right? So even in both the cases, the upper class limit is 20.
But you said that upper class limit is the largest value that can go inside a class. But then we're saying that we're only going till 19. So shouldn't 19 be the upper class limit?
No. I mean, it won't be. What will happen if you have, let's say, 19.99 in the data set?
Oh yeah. All right. So we're looking at the integers then.
Not really. I mean, here we're
As the
talking about
limit.
the continuous data.
Sorry?
We are talking about the continuous data, right? So you are dividing your data set into different classes. So even though this class doesn't take the value 20, but still the value will be very close to 20, right? It can take, there will be very small, what do you say?
difference.
Yeah, between whatever 19.99, but it is treated as somewhere 20, right?
Yeah.
So we take, I mean, upper class limit will consider as 20, but still we will not take 20 into this class. We'll have to take 20 into this class.
Okay, got it. Thanks.
Yeah. So when we talk about the class width, what we say is, you take the lower class limit of the next class. I mean, next class, and after, like, this, in this case, you have 10, 20, 20, 30. So I will take the lower limit of 20, 30, and I will subtract that from the lower class limit of the 10, 20. So that will be your class width. So this I can write it as a difference of
Lower and next higher.
lower class limit of
consecutive intervals.
yeah, that is better. So difference between the lower class limit of consecutive intervals.
Ma'am, we can also say the difference between the upper class limit and the lower class limit.
That also we can say, yes. Now there is something called the class mark. So class mark is defined as the average of two class limit. So if I talk about the class mark of 10, 20, so what will be the class mark of 10, 20?
15.
15. Yeah, so class mark is just average.
Average of upper limit plus
Yeah,
by 2.
two class limit in a class. Right?
Midpoint value of a class.
Yeah, average of the two class limits of the class. I mean the lower limit and the upper limit. Okay. So any doubt so far? Whatever we covered. Does anybody have any doubt?
No, ma'am, go ahead.
Okay. All right. So far we looked at how do
Excuse
we,
me, ma'am.
yes.
Can we ask activity questions?
I will take the questions, but today let's finish the theory first. Yeah.
Okay, ma'am.
Yeah.
मैम क्लास इंटरवल का डेफिनेशन क्या है मतलब does it only you should मतलब like 5 class you have 100 numbers then if you choose 5 classes or 10 classes there will be around 10 intervals. Is it that only or is it defined in any way? मतलब is it
No.
just an interval?
Class interval is this is what the class interval was. So when we are saying this is my class is, let's say, 10, 20. Okay. So let's say this is class. So when we talk about class interval of this, it will this interval will contain the value 10, but it will not contain the value 20.
That I am getting, ma'am. See, what is a class? Interval मतलब क्या है, ma'am?
Interval as in like you are splitting, you are dividing.
That I'm understanding, ma'am. See, is there any definition to it? Because for this small classes, for this small data, there's not a problem. We are understanding it, even if there is no definition. But as the data grows or the data set grows, then how should we actually interval कैसे create? How should we create the intervals actually? Are there any rules for it, or is there any definition for it? This is how you have to deal with it.
No,
Or it is just you divide into 10 equal parts or 20 equal parts or 100 equal parts. If its data is bigger, just divide into n number of parts. Is it like that only? Or does it?
Okay. So like you have to look at the data set, and the first thing is you should also look at what is the lower value data set is taking and what is the higher value that your data set is taking. And depending on that, you look at some patterns in the data set, like or even you don't have to maybe look at the pattern. You decide your own number of classes. Okay, depending on
Ma'am,
like
actually,
you
why
don't-
am I having a problem is Fibonacci series I've taken just to take
Okay.
a series. It doesn't have a absolute, like 1 to 100. You have an absolute interval in between numbers 1, 2, 3. There's only a difference of 1. But in Fibonacci series, actually, that interval varies. Now, if I have to deal with a class interval, is it the number? Should I consider key? There should be so many elements in each class.
No.
Or,
That should not be your concern. That should, I mean, you should not think of it like when you are dividing your data set into different classes, you should not worry about that. In each of the class, I'm going to put specific fixed number of observation. This should not be your concern. You should just deal with, you should just think about I mean, you should just decide on how many classes do you want for this data set. Okay, and accordingly you divide whatever classes you come up with, whatever classes you think is suitable, then accordingly you divide it into uh, classes, right? So let's say if you have come up with some 5 classes, then you look at your data set, like you look at each of the observation, and then you see, like let's say I make 5 classes. Okay, so you look at, you have different data set. So let's say I look at this observation and I check if this observation is false in this class or this class or this or this or this. So whichever class this data set will fall into, I will put this into that class. So let's say this data set, this observation falls into this class. Okay, then I will go to the second observation and again see which class to this observation falls into. And similarly, it goes on. Yeah.
Okay.
Ma'am, isn't class width and class interval same?
Class width and class interval same. More like yes, I would say yes.
Ma'am, if the series is like is having equal number of numbers or there is some similarity in it, then it might be okay. But the series is it's varying a lot, then how can they be same? Because you are saying the number of elements in an
Ma'am,
interval.
not same.
No.
Because interval is end boundaries include नहीं करता.
No. So I mean, yeah, you will not know that how many data
Elements in
points.
the interval you have, you will not know if the data set is big or if it's not even, or if it's not having some pattern.
No, you
So
don't have to look at the pattern. No, first.
then how can they be same, ma'am? It is difficult for them to be same, Nathan, unless it is
What to be same?
that class interval and class width. Even if I
So
take, we're talking
class.
about Fibonacci series, for example, you can never have a class interval and width of same. They cannot be both same.
No, when you what I said is, like when you talk about the class width, right? So class width is just you take any class and you look at like what is the difference between the upper limit and the lower limit. So any class you take, right? Let's say I take this class. So class width will be same, right?
No, class width will be same, but class interval and class width, don't know how can they be same for it. Anyway, ma'am, go ahead, ma'am. I think so. As we go ahead, it will be clear.
Okay.
Focusing on one point.
I just want to confirm that if
Hmm.
it is like for a given interval is 0 and 10 are the values, the lower values, and the upper values is 10. So the 10 will not be included because it is the upper class limit, but it will be like the part of the interval now.
Yes. Okay, let's move to the next topic. Okay, so next we have, like, if you have continuous or numerical data set, So in that case, how do you represent your data set graphically? So one way is you plot the histogram. And the second way is you make stem and leaf plot.
When class interval is a discrete data or I mean continuous data.
I mean, this is class interval. How can it be a discrete or continuous data? I mean,
We cannot consider it discrete or continuous data. It's only consider.
okay. So what we're talking about is how do you represent graphically your numerical data set? So one way is to plot a histogram, and the second way we'll look at is plotting the stem and leaf plot, right? So when you plot, so how do you construct a histogram? So you will have from your data set, you will construct a frequency table, and on your horizontal axis, you put the classes. Horizontal axis, you put the classes, and on the vertical axis, you put the frequencies, right? So this is how you basically plot the histogram. So histogram will look more like something. This is also a histogram, right? So it's like I have split, let's say, my data set into 10 equal intervals: 40, 50, 60, 70, 80, make it maybe 90 and 100. So let's say this histogram represent the marks obtained by students in a class, right? This can be let's say this is the representation. So what is it showing is in each of the class how many students are there. So the length of each of these bars that you see, that will give you the frequency. This is the frequency. Okay, so this is how you plot the histogram. So has any one of you tried plotting histogram in the Google Sheet? Nam has done in the lectures, but has any one of you tried it? No one tried it? Okay. So maybe it will be a good exercise for you to take some data set, or you only generate some data set, or take some data set online and take some numerical data and try to plot the histogram and see try to find out what are what is the lower class limit for each class, what is upper class limit, what is the frequency. You can try out these things as an exercise. Okay, now in stem and leaf plot, what do we do is if you have a set of observations, okay, let's say you have let's say you have some observation, okay, you have different observation. So for each of these observations, you keep the rightmost digit for the observation. Let's say if your observation is, one of the observation is, let's say 26, then I will keep this rightmost digit separately, and whatever is left, I will keep it separately.
True.
Yeah. So the rightmost number in any observation, we call it as leaf. So there are two components to it. So one is leaf and other is stem. So the rightmost becomes the leaf, and whatever is left becomes the stem. So this is how you will represent it. Now let's say I add one more value to it. Let's say I say 21. Okay. So again, in this case, in the leaf, you will have 1, and in the stem, you will have 2. So now 2 I already have in the stem. So I just need to add 1 to the leaf. So I will not, like you will not write 6,1, right? So what you do is you write these in ascending order. So you should first write 6, and then you should write first you should write 1, and then you should write 6. And or a more proper way would be, like whatever a data set is given, you first sort it out, like you sort it into increasing order, right? So you sort it out into in increasing order, and then you identify the stem and the leaf, and then accordingly you write, accordingly you prepare your stem and leaf diagram, right? If I can add, let's say 30. So again, you see, I need to maintain the order. So even though 0 is a leaf and 3 is a stem, so you see 3 is not in the same stem. That is, initially the stem was only 2. We only had 2 in the stem. So now we need to add 3. So we will not add 3 before 2. Okay. We need to add 3 after 2. So there should this order be maintained. So this should be increasing. So as you move from top to bottom, the number should increase in the stem. And as you move left to right, these numbers should increase. Okay.
Ma'am,
what
if we
Oh, sorry, one by one, please.
If it is a 3-digit number?
So what happens if it's a 3-digit number? So let's say my number is 226. So in this, what will I keep in leaf and what will I keep in stem?
Will it be 22 in stem?
I think 22 will be stem
22
and 6 will be leaf.
Stem and 6 will be leaf. So you always, whatever the rightmost digit is in the observation, that will be the leaf.
So
And
always
remaining-
1's digit is in leaf.
Yes.
I think it is not relevant for very big number.
It is not relevant for
Very big, very large number.
a very large number. Yeah, it won't be a better way to do it.
It can be difficult.
Yeah.
Ma'am, then we should write stem in 22 now.
Yeah, we should write stem. Okay.
Ma'am, firstly we arrange data in ascending order.
Yes, first we arrange the data in ascending order. Then we identify the leaf and the stem, and accordingly we write.
Okay.
Ma'am, if we write 7 only?
7 only.
Yes,
mean-
ma'am.
You have only 7.
Yes, ma'am, only 7.
So see, this is the only digit. So what will happen is, in the stem, you can write this as 07, right? So maybe you will go 0 there and you will have 7. What? Your voice is breaking. I'm not able to hear. If you can type, I will take it from there.
Ma'am, I'm saying that, ma'am, am I audible now?
Yes, now you're audible. Yeah.
Ma'am, in 226, how, like, 2 is a stem. Can you repeat that, please?
Yeah. So what we said is, whenever you have to make the stem and leaf plot, right? So you will always take the rightmost digit in the leaf. Okay. And whatever is left, you put it in stem. So when we had 226, so the rightmost digit is 6. So I put this into leaf, and this 22, I put it into stem.
So, ma'am, a leaf will always contain 1 digit.
1 digit.
Okay, ma'am.
Yeah. Let's do one problem to understand it better. So, okay. I will give you one question. So let's say the data set is 17, 90. Let's not go to 91. So 19, 31, 25, 56, 11, 32, 29, 3, 5, 6, 7, 8, 40, let's say 30. So can you make a stem and leaf plot for this?
Yes, ma'am.
Yeah, ma'am, we can.
Yes,
Yeah.
ma'am. Firstly, arrange in
Can you try it out? Try it out. First try it out.
What is the number be after 40?
Okay, so just take a minute and try this out, and I will ask you in
The number after 40, ma'am.
30. It is 30.
Ma'am, done.
Done? Okay. So okay, so I will make the plot here. You tell me. So in the stem, what all values did you put?
1, 2, 3, 4, 5.
5. Yes, ma'am. 1, 2, 3, 4, 5.
3, 4, 5. Okay. And in the leaf with 1, what did you put?
1,
1,
7,
7,
9.
and 9.
1, 7, and 9. In 2,
5, 9.
5, 9.
5, 9. In 3,
0,
0,
1,
1, 2.
0, 1, 2. 4,
0.
0,
0, 5,
6.
6.
6. Right? So it is clear for all of you. Yeah.
Yes, ma'am.
Yeah, ma'am.
Okay. All right. Good. Let's move to the next topic. Okay.
Ma'am, in the definition of the stem plot, like it is given, ma'am, just a second.
Yes.
Think of each observation as a stem
Yes.
consisting of all but the rightmost digit and a leaf the rightmost digit. Why even 2 times rightmost digits are used? Like it should be the leftmost, now for the stem.
No. So what? So when we okay, I'll just read it out. Or maybe let's write it. So the definition says, each observation is separated into 2 parts, right? Separated into 2 parts. And that is stem and leaf. You have stem and you have leaf. And what we're saying is a stem consists of all but the rightmost digit. So here you look at it. It says it consists of all. So whatever, let's say my observation was 5, not 1, okay? So the stem will consist of all. It means everything but the rightmost digit. Except, so when we say but the rightmost digit, it means except the rightmost digit, everything else will come into stem. And
Okay,
leaf,
Yes, ma'am.
leaf is the rightmost digit.
Yes, ma'am, got it. Thank you, ma'am.
Yeah. But why it is in stem all but the rightmost and the leaf for rightmost? Since one is no. This is how you write. It's just the language, I mean, when you write a stem consists of all but the rightmost digit, it means everything except the rightmost digit will go into stem. And leaf is the rightmost digit. So leaf, so whatever you left the rightmost digit, that will go into leaf. Okay, it's just a way of writing in English.
मैम
That's all.
सच में इसको कहीं पे यूज होता है क्या मैम? इसका कोई प्रैक्टिकल पर्पस है क्या स्टेम एंड लीफ ग्राफ का?
Generally use नहीं होता है ज़्यादा, but mostly you will see histogram only.
Okay, ठीक है.
But this is one way to represent. Maybe if you have smaller data set, this will work.
Okay.
Okay. Okay. So now let's look at the other topics. So next we'll move to measures of central tendency. So now you have the data set, and you want, I mean, you just not want to like see the data set, or like first we saw if you given a data set, how do you represent it? I mean, how do you put it into frequency table? And once you put it into frequency table, how can you visualize your data set? But we would want more from our data set, right? We just don't want to restrict ourselves to knowing the graph and so on. We would also want to see that where exactly my data set, most of my data set is, or like what is that number where most of the data set is accumulated, or if we have the data set, how much spread is there in the data set? So all that we want to my data set should capture, right? So all that we want to know. So measures of central tendency, this what it says is like you want to know where exactly most of your data set is centered, right? So there you will study three different measures. So one is, the first one would be mean, second will be median, and third will be mode. Yeah. So all are measures of central tendency, and in a way they give us an idea of like where most of my data set is centered, right? And you will also look at measures of dispersion. So there we have 5 different things that we will look at it later. First, let's look at measures of central tendency. So what does it give? It gives where exactly my data set is, like it gives the center of a data set in a way, gives the center of a data set. Okay. So how do you define the mean?
Sum of all observations upon total observations.
Yes. So
Sum
mean,
of observation by
yeah.
total number.
So for a data set, mean is sum of observations
by the total number.
Divided by total
Number of observation, total number of observation.
Yeah. So for, let's say you have data set as, my data set is x1, x2 up to xn. Okay. So what will be the mean?
X1 plus
X1
X2
plus X2 plus
Average.
Xn
Right.
divided by
x1 plus x2 plus xn divided by n.
N.
And there is one notation for mean, and this we denote as an x bar.
X bar.
Yeah. then you have there are two things. One is when you're talking about when you're dealing with sample and you want to find the sample mean, and then you also have when you have the population and you want to find the population mean, right? So when you have a population, when you want to find the sample mean, so sample mean, so I denote it as x bar, and this is given as x1 plus x2 plus up to xn by n. Then there
N
is
minus
something also called population mean.
But you write it sample means. Ma'am, I think sample mean is wrong.
No, sample mean is right. Then you have population mean.
N minus 1 divided by N minus
Sample mean should be n minus 1 here. Right?
No,
Yes,
no,
ma'am.
no, no.
Sample mean is n minus 1.
No,
n
no, no, no,
minus
no.
1. There
No,
should
no,
be
no,
n
no.
minus
It is not n minus 1. It is n.
Not n minus 1.
No,
it's
ma'am.
n
Population
only.
for a population we
Okay.
have.
It is for variance. It is for, yeah. It will be denoted by capital
Not
N,
for me.
population mean.
It is not a sample variance.
Here we're talking about sample mean,
Yes, ma'am.
and this is population mean, right? So, I mean, when you are finding the mean,
So I have a one doubt. What is
yeah,
difference between small and capital N?
yes, I'm going to tell you. So you have so let's say you have a population. Okay, let's say this is my population, and this population have, let's say, capital N data set. Let's say I have x1, I have x2, and so on. And let's say I have xn, capital N it is. And now from this population, you are taking a sample of size n. Sample of size small n. Okay. So let's say this is my sample. So I am denoting the sample as, let's say, sigma. So I will have some x1, x2 up to, let's say, quantile xn, small n. So I will have small n. I mean, these. So in the sample, you have x1, x2 up to xn, this data set. But in the population, you have x1, x2 up to xn. This is capital N. This is small n.
Ma'am,
So
basically
when-
it's a size of the data set, but necessarily both of them are averages only, right?
Yeah, both of them are
No,
averages only.
average only. It's just the size of data set. The number of
Yes.
elements are more, yeah, a number of elements are less.
Yes, yes.
Right. Okay. Thank you.
So in both the things, you are doing just the average. This is how you define the sample mean and the population mean as.
Ma'am, sample mean is a subgroup of a population mean.
I mean, like when you say subgroup, what do you mean by it? What do you understand by
It is a
subgroup?
part of the population, not a whole.
Subset. We say subset.
See, first of all, sample is a subset, right? When sample is a subset of the population. But why, first of all, why are we looking at both the population mean and the sample mean? So you will study all this later when you go to stats too, but just for you to understand. So sometimes, let's say my population is not so big enough. Let's say I can easily find, I mean, I'm not really interested in trying to infer something from the population. I just want to, whatever my data is given, I just want to see what is the mean of it. So I know in my data set, I have n x1, x2 up to xn numbers, right? So if you have to find the mean, it will be just x1 plus x2 plus up to xn divided by capital N. But now let's say when you go to inferential statistics, then there in that case, let's say you want to whatever data set is given, you want to infer something from data set. You want to know more about the data set, and looking at data set, let's say you want to make some hypothesis or make some conclusion about the data set. Okay, so in that case, you don't have the bandwidth, or let's say something which for which you're not able to work with the complete population. So in that case, you take a smaller sample and you study the sample and then you try to work on it. So in that case, the sample mean will come into the picture. So the sample mean will have, it will be even the sample will be a subset of the population, but the size will be smaller. And we are saying the sample will have a size of, the sample will be of size small n, and the population is of size capital N. Okay.
Yes, ma'am, go ahead.
Yeah. Okay. Then we have something called the group data. You have mean for group data. So see, you have learned how do you how do you make the frequency table, right? Because you would not always want to go to each and every number and find the sum and take the divided by total number of observation. If you are able to group your data set the way we did earlier, so if you are able to group your data set, it means if you are able to see, let's say you have the date in the data set, let's say you have 1 2 3 4 5, okay, and you know number this is, let's say, frequency, and you know one has occurred, let's say, 2 times, 2 has occurred, let's say, 1 time, 3 has occurred, let's say 4 times, 4 has occurred, let's say 2 times, 5 has occurred, let's say 1 time. So when you know that, I mean, each of these data set has occurred these number of times, it is it is much easier to calculate mean in such a way such that I mean, if you know one has occurred 2 times, so you can directly multiply 2 times 1, right? If you know 2 has occurred 1 times, so this is just 2 times 1 again. You know 3 has occurred 4 times, so it is just 3 into 4. I mean, you will have if you add, because when you're finding the mean, what you have to at the end you have to do is you have to add each of these observation and you divide it by n. So if you know that my 1 has occurred 2 times, 2 has occurred 1 time, so from there you can find the sum of all the ones at once. You can find the sum of all the 2s at once. You can find the sum of all the 3s that have occurred at once. And then, so this is nothing but your Fi Xi. So let's denote this as Fi, frequency is Fi, and all these are Xis. So I can find these, and the total will give me sum over Fi Xi. And this is nothing but
29 by 5.
Yeah, I mean, you can calculate it. And this is not, this sum over Fi Xi is nothing but your sum over Xi, right? I mean, if you look at, I mean, when you don't put these Xi into frequency table, let's say if my data set was 1 1 because 1 occurred 2 times, then you have 2 because 2 occurred 1 time, then you have 3 3 3 3, then 4 4 and 5. So adding all of this is same as doing this, right? You
Yeah.
agree with that?
And this is a discrete single value data. What about the
Yes.
continuous data?
Continuous data, again, you do the same thing. So in that case, now you will have okay. So now you have continuous data, right? What is happening in the chat? Okay. Mean for group data, and now we are talking about continuous data. So see, when you have continuous data, you will have you have different classes, right? You will have different class intervals. So you will have more like the class interval is given. Then you will find the frequencies, which is f of I. Then in case of the continuous data, we also look at the midpoint. So let's note it as mi. And before, when we had discrete data, we did fi xi. So in this case, since we have no longer discrete data, we only know the class interval. So what we can do we can find the midpoint of the class interval and then do fi mi, right? So this is what can be done. So let's say, for example, you have class interval to be 10, 20. Let's say the frequency is, number of observation that has fallen into this interval. Let's say it is 5. So what should be the midpoint of this class interval?
15.
15. And now we find FIMI. So 15 by 75.
75.
Let's say I have some other class interval. I take now 20 to 30. And let's say the frequency is 2. So midpoint will be 25. And this will be
50.
Then you have 30, 40. Let's say I have one more. Can you mute yourself first? The voice is breaking for someone. So you have 40, 50.
Ma'am, but this is all approximate, right?
Approximate. This is approximate.
Right. Okay. Right.
So 30 to 40 will give, let's say the frequency is 3. So the midpoint would be 35, right? 35 into 3 is what? 105?
105.
Yeah. In this case, let's say frequency is 1. So you have 45, you have 45. So when you find the mean, so mean will be sum over FIMI
by n
divided by
175 by
number of the class.
Yeah. So this is what?
175.
175. It will be much more than that, no? Because you have 5, 5, 10, 15. You have 1 over here, 7, 5, 12, 12, 4, 16, 117. You have you're 275.
Sorry.
Yeah. So you will have 275 divided by how many observations we are looking at?
11.
11. So this will give you the mean.
So, ma'am, the smaller the class interval, the more accurate the data is, right?
Yeah. In that case, we'll say it is more accurate.
Right.
Yeah. But generally, like this we are talking about like something that we can solve in a notebook, right? But in general, in practical, this will not be the case. So you will have different class interval, and whatever you get, it will be approximately, will be approximately same as what you get.
Because, ma'am, just if you're seeing that 20 and 30 is your class interval, you have two observations actually, 21 and 22. And the midpoint you're taking is 25 and the average you're getting is 50. But if the class interval is, so there'll be a huge variation within the class itself.
Yeah, there will be variation. Yeah.
Right. So smaller the interval, the more approximate data. Even if the larger data set, we should try and find out a little smaller interval so that you get an accurate data. Basically, that is the point, right?
Yeah. So like in this example, if we had only 11 data point, so in that case we need not even make the class interval, no?
Right.
So
True.
yeah, it will generally be very higher frequency. Then in that
Right.
case, the midpoint will make sense.
Right.
Yeah.
Right. Thank you.
Okay. Yeah. All right. So this was about mean for group data. Then we will look at after this, there are some properties that your mean will satisfy, and they're quite mathematical and intuitive also. You can think about it. So the first is like what happens when you add a constant to a data set. So let's say my data set is, say, adding a constant. Right. So let's say my data set is x1, x2 up to xn. Okay. Now what I'm saying is, let's take now my new data set is x1 plus c, x2 plus c, so on xn plus c. Okay. So if I had to find the mean of x1, x2 up to xn, so mean would have been x1 plus x2 plus xn by n, right? And now if I add a constant to each of these data point, then what will happen to the mean? Again, you will add, in this case, you will add everything. So you will have x1 plus c plus x2 plus c and so on till xn plus c divided by, still its number of observation is n, right?
That's one.
So this will become x1 plus
You should just add c to the mean. That's it.
xn plus n times c divided by n. So this is nothing but this is same as, so if
Adding
I
c to the
note it
mean.
as, yeah, so this is same as x bar plus c. So if your original data set was x1, x2 up to xn, and you add a constant c to each of these data point, then the final mean that you will get, it just you add this constant to the previous mean. Okay. Then next would be multiplying a constant. So can you tell me what will happen if you multiply a constant?
X bar into C.
X bar into C, yeah. So now if I have yi equal xi times c, then my y bar will become x bar times c. You can prove it the same way, the way we did for adding a constant. All right. Then next we have median.
Ma'am, what about the outliers?
Outliers will come to. It is after this.
Okay.
So let's first understand what are all these terms. So next is median. So what do you? So median is again the middlemost value. It just, I mean, this is also used to represent the center of the data. So how do we find the median is you divide the data set in, first you sort the data set in either increasing or decreasing order, and you pick the middlemost observation, the middle value in the order list. So it will be the middle value in the ordered list. So there can be two cases. So one is when,
excuse me, ma'am.
Yes,
Y bar equal to x bar c.
That I have written for, like, before we saw that what happens when you add a constant. Now what I'm saying is, now what happens to the mean when you multiply a constant to each of the data point.
Okay.
So median is the middlemost value in the ordered list, right? So there are two cases that can occur. So one is when the number of observations are even and when the number of observations are odd, right? So when the number of observations are odd, then you know that there will be equal split. I mean, you can easily divide the data set into two parts where one observation would be left. So that will be the middlemost observation. You can say that is the median. But in case the number of observations is even, then you will have two observations. I mean, you will be able to equally divide your data set, right? So in that case, how do you choose the median? Because nothing is left after you split the data set in two parts, right? So what you do is you take the two middlemost observations, so these two, and you take the average of these two. You find the average of these two. So this will give you the median.
Ma'am, actually, median practically where do we use? Like for example, average you do it in class average or many other places, but median, what is the practical value of median? How does it matter whether it's a center value or if it's not a center value in any data set? Because when you're dealing with a data set of, for example, 10,000 or 1 lakh, you don't know, then how does it matter whether you have a middle value, one value, two values? But where will you use it actually practically?
Practically, okay. So there are some cases where basically see both mean and median gives you they both are the measure of central tendency. It means finding whether the mean or finding whether the median, they give you an idea where your most of the data set is centered around, right? So
no, ma'am. Median for average, yes, but for median, no. For example, again, if I'm talking about Fibonacci series only, you will have if you see the median, it will not be anywhere near average.
Fibonacci series is what? Fibonacci series, there everything is like different, no? I mean, you have it starts from one.
There's a pattern. There's a pattern, right?
It's a pattern.
Right.
So
I'm practically dealing with data and I'm seeing there are many places where you don't have an equal interval. So in good number of places actually. This is one example where people can understand that there will be a big difference in the interval actually. That is the reason I'm taking this example from them. But the point what I want to make is for average, you can take a first value, last value, and you can find out something. For median, many places, it doesn't really make any practically that data you're not going to that data how you're going to use it in any situation, that is little difficult to comprehend actually. But can you give me an example or anywhere practically which makes sense to use median somewhere?
So like when you see a histogram, right? I mean, when you plot a histogram, so maybe you're just given a histogram, and when you have to just get a sense of where do you see like the middle most value is. So there, from there, you just get an idea. Okay, like this is okay. Let me just plot this first. Okay. Something. Oh, okay.
Ma'am, we'll get it back in the last once the class is over, we'll get it back.
Okay, we'll get it back on this. Yeah. Okay.
And can you elaborate with some example of Even?
Yeah, I can do that. Let me take one example. Okay. Let's say my data set is 1 5 6 2 9 7 8 3 2 3 and 6. Okay, so can you find what is the median?
9 plus 7 by 2.
9 plus 7 by 2. Okay.
Madam, it should be arranged in order.
First of all, we are arranging.
Yes. So you need to arrange. You have not ordered it first. So you need to arrange first. So let's say I arrange it in ascending order. So you will get 1, 2, you have 2, then you have 3, then you have 5, you have 6, you have 6, you have 7, you have 8, you have 9, right? So now you see number of observations are 10. Number of observation is 10. So this is the first 4, this is the last 4, and the middlemost observation is 5 and 6. So now you take the average of these. So it will be 11 by 2, which is 5.5.
Ma'am, but 5.5 is not in the set. So can we consider 5.5 as a median also?
Yeah, it is okay. I mean, it need not be a data set.
Okay.
I mean,
Yeah, ma'am.
Hmm.
Ma'am, I was telling about what about the group
Means what do you
group
mean?
data?
Group data.
Are we considered this in the median?
I mean, even in that case, see, you cannot talk about the group data here because how will you sort it out, right? I mean, you need to, like in this example,
We can get CF, cumulative frequency.
but you won't know the exact values, right?
Ma'am,
The
if it is
central
in
numbers, you'll never know the central numbers. So
if it is in
there's no
discrete, then we can find, right?
Yeah, if it
only in
is
discrete.
if it is discrete, then I mean it's the same thing, no? I mean, you don't even have to yeah, I mean, do the same thing.
Ma'am,
And
can
you
we
can
have an example for the discrete?
let's take this example only.
Yeah.
So this is written on this way. So you have 1 2 3 4 5 6 7 8 9 10 10, right? Now this is how my data set was, and I arranged it in ascending order. Now the first 4, last 4. So you see the median will be just 3.
Ma'am, here also order matters, right?
Yeah, order matters.
Ma'am, then if you add some number or if you remove some number, then whether median changes or won't change, will such problems come in this thing?
Like how?
Like average, we were having some arithmetic problems, right? Ki if you add some
Yeah.
number or multiply some or something, whether the median changes or not.
Yes. So what
So-
happens? Okay. Let's look at that next. So what happens when you add a constant? So what we are saying is you have the data set x1, x2 up to xn, and now you are adding c, let's say a constant c, to all of them. So do you think adding a constant is going to change the median? Yes or no?
It will change, ma'am.
It will change, no? And how much will it change?
By that value only, by that C value only.
C.
The C value only, right? Yeah. So I will say the new median will be old median plus C. And what about multiplying a constant?
New median is equals to old median into C.
Right?
If
So
it
you
is
will have,
odd, if it is even,
what?
if it is even,
How does it matter?
if it is odd,
Hmm.
then only you have only one number you will be multiplying with C. If it is two numbers, then you take C out common and there will be a by 2, right? So
Okay.
then C by 2, anyway, that number will be, right, ma'am. It doesn't
Right
make a
now?
difference.
Yeah.
It doesn't make a difference, right?
Doesn't make a difference. So
We are just multiplying and add some constant values.
yeah. So C times the old median. Right?
Ma'am, you said that the median does not necessarily have to exist in the data set, right?
Yes.
But then what exactly are we finding?
We are finding the middle, like these gives the, like, in a sense, middlemost observation. I mean, where the data, where we see most of the data lies.
But we don't
So it
have
is
that.
just, yeah, it is just a like number which we are saying, like, my data set is around this number, no? I mean, this is the value that that is occurring in the middle of the observations.
Could you
on
just
it.
scroll up to the example?
Yeah, here you
Yep.
get
So-
5.5.
So 5.5 because the two numbers that we got were 5 and 6, and 5.5 is between them.
No. I mean, when we talk about the median, we are not talking about the two middlemost observation. We are talking about the median for this data set.
Yeah, like for this specific example, I'm saying because it was an even number, like n was equal to an even number.
Yes.
So we cannot get one single value. So we got two values here, and because we want one single value, that's why we divided by 2 to get like an average of these. And that came out to be 5.5, so that gives us one middle value.
Yes.
Can we conclude that?
Yeah, I mean, that will be just one value, right? So we want the middlemost value. So we had like even number of data sets. So if we look at the middlemost value, you will have like 2 in between. So you take the average of it, and that will be the median.
Ma'am, just like that, if you have 1 and you have 4 twos, then you have 6, 7, 8, 9. Then your median will be 2.
Sorry, you have 1
and 4 twos.
1 and 4 twos. Okay.
Then you have 6, 7, 8, 9.
Then you
your
have 6,
median
7, 8, 9.
Then your median will be 2, right?
No, then your median is 2. Yeah.
So
This is the
what
middlemost
picture
value.
does it give? What picture does it give me about my data set?
It is just which value.
No, ma'am, that is what practically. How will it help me in anything? Matlab, what picture will I get from this?
So I think like
You can apply that.
Because we're
Huh?
arranging
You can apply
this.
missing values.
What?
Sorry, can you repeat?
Missing value in data set, some missing values there. Some that time you can apply that median or mode values.
When you say missing data, what do you mean?
Missing means data
Or
set
if I give,
not
for
given that
example,
value.
I have 10 which is missing, which actually there is to be. In that place, if I put 2, in what way will it help me?
That time you check in that is 10 is there.
Anyway, ma'am, let's go ahead.
Let's
See.
let's take it at the end, or we can have a discussion on that. Let's finish this first. Okay. So we looked at how will the mean and a median will get affected if we add a constant or multiply a constant. Then we have something called mode. So mode we have also seen earlier, and this is mode is whatever values is frequently that has occurred the most frequent. The most frequent value is called the mode, right? So how do you find the mode? So you just have to check like which number has occurred the most in the data set, and that will give you the mode. So the greatest frequency in any data set is the mode. And how will the mode affected if you add a constant to the data set and if you multiply a constant to a data set? What will happen if you add?
It will be
simply mode plus constant will be the next mode.
Sorry.
If you add
Same
mode
as a
plus
median.
constant, mode plus constant will be the next mode.
Same as median affected.
Yeah, same as median, right?
Yes.
So the same thing will apply for this also, mode also.
Mode.
And in a mode, we have get two values.
Then that will be called bimodal data set.
Okay.
Yeah. Okay. All right. Then you have something called the outliers. Okay. So outliers, if it's covered in this lecture.
Then percentile is remaining.
Yeah. Two, three more lectures are remaining. Yeah. Okay. So there is a term called outliers that we will see. So outliers is something you can think of outliers as something which was not expected in the data set, or like let's say some value. For example, let's say in the data set you have 2, 3, 9, 5, 10, and suddenly let's say you see a number 100. Okay. This is just one example that I'm giving, something that is very unexpected to happen, but sometimes there may be some error or because of some reason. If you observe something like this, I mean very unexpected, because all these data sets are very values are very small, but one value you see which is quite high. So this is an outlier in the data set. So it affects your mean. It will affect the mean, right? I mean, even though the purpose of the mean is to see where your data set is centered, right? I mean, where does your data set lie? Like most of the data set lie. But when you find the mean in this case, it will, what will you get? You'll get 9, 10, 12. Okay, let's make it, add one more number. 3. Okay.
It's changed the real value of the mode.
Sorry. So yeah, what do you get? It should be 130 by 7, right? The mean should be 130 by 7. And what it is, it will say 19, right? How much it will be?
18.5.
18.5, right? So you see, even though this is not a very good example that I have taken, but it's like this in a sense doesn't give you an idea that most of your data set is around 18.5. This looks quite wrong. So median, like mean, is quite sensitive to the outliers, the sample mean, or in general mean. Like it gets affected a lot by outliers.
A scatter plot, yeah, see outliers.
Then, but this is a good example for median, right? Median will not give you that error.
Yeah, median will not give you the error. Yeah.
Okay. No, it answered my question actually. But when the case of outliers, when you have, then you can actually
median will not.
Median works.
Median
so if there's a big
give you the
difference
error.
between median and mean, then you can get a picture out ki there's something wrong in the data. Right.
Yeah.
Right. Okay. Thank you, ma'am. Thank you.
Yeah. Thank you. Okay. So next we'll go to measures of dispersion. Okay.
Can you please once again explain this?
Explain this. Yeah. So let's see. Maybe I'll take some different example. Okay.
Ma'am, time is short. Percentile also should be explained. So.
Yeah. Time is short. Right. Okay. So what I was saying is see, when you look at this data set, right? So you find the mean, you get 18.5, right? But in like, how does it look like? It is like 1, 2, 3, but mean should give you an idea of where your data set is actually centered. But 18.5 is quite like it is not giving you an idea, like, because you see most of the data set is like between 1 to 10. So I would expect the mean to be somewhere there, but it is 18.5. So because of this 100, right, which has occurred like very unexpected, this has come. So because of this, it is putting a big difference on the mean that you should have gotten. So mean is quite sensitive to outliers, where while median, when you look at median does not change, right? So median in that case may be a better way to see where the middlemost value is. Yeah. Okay. So next is measure of dispersion.
It means comparatively to mean, median and mode is not sensitive to outliers.
Yeah, median and mode is not sensitive to outliers.
Okay.
Okay. So mean just give you the picture of where the center of the data set is. But it is possible that you have two different data set, and the mean that you get or the central value that you get is same, but maybe the data set are not same. So there should be something else we should look at, which gives you a better picture of what is happening in the data set. So to decide on that difference, we also look at measure of dispersion. So here we have like 4 different things that we'll look at. So first is you have range, then you have variance, then you have standard deviation, and then you have interquartile range. Okay. So what is range?
Maximum minus minimum.
Outer limits.
Difference
of an
between
Yeah,
maximum
so
and the minimum.
range is just the difference between the
Maximum and the
largest and the smallest value.
yeah.
Largest value minus smallest value. So this is basically max minus min of a data set. But this is not a good way to find the dispersion in the data set, because again range will be very sensitive to outliers, because let's say something like this happens and we will say the range is, in this case, is 99, but it is not taking into account all the data, all the observation that you have in a data set. It is just looking at what is the maximum value in the data set, what is the minimum value in the data set, and this is just giving you the difference in that. And we are saying this is giving you an idea of dispersion in data set. But when something like this happens, because of outliers, the range can be quite high. So we need something which is like, which takes into account all the observations that you have in data set. And this is where the variance, this is something variance takes care of it. So in variance, what you do is you have the data set and you take the average of, so it will be like sum over xi minus mu whole square divided by n, I varying from 1 to n. So whenever you have to find the variance of a data set, this is what you do, where mu is the mean of the data set.
Ma'am, outliers affect range.
Yes, outliers affect range. This is what I said, right?
Yes, ma'am.
If you did not have outliers in the data set, and let's say I have the data set just as 1, 2, 3, 9, 5, 10, let's say 6, then in this case, my range would have been just 9. But in this case, my range comes out to be 99 just because I've added 100 over here, right? So again, like the way you see in mean, you could find the sample mean and you could also find the population mean. Even in variance, you can find the sample variance and the population variance.
Ma'am, will variance reduce the, is variance sensitive to outliers? If you minus mu from each and every observation and square it, will it reduce the effect of outliers, or is it sensitive to outliers?
It is not sensitive to outliers variance.
Range is sensitive.
Sorry, can you repeat?
Range is sensitive to outliers, not variance.
Because we are removing the average from each and every
Yeah,
observation.
you are removing the average from each and every observation, and then you are taking the square of it.
Yes, ma'am.
So yeah, where were we? Yeah, the sample variance and the population variance, right? So okay, like as in sample mean and the population mean, I mean, it is just a matter of taking the average. So like if you are finding the mean for a population, you find the average of all the data set. Or if you are finding the mean for a sample, you take the average of all the data set. But in case of variance, so when you want to find the variance for a population, so I will go to the same notations that we have used earlier. So it will be this. So when we have to look at population variance, so let's note the population variance by sigma square, and this would be sum over xi minus mu whole square divided by capital N, and I is varying from 1 to n, and where mu was a population mean. And when we have to talk about sample variance, let's denote it as s square, and this will be sum over xi minus x bar whole square, I varying from 1 to
Now
n.
it's n minus 1.
It is n minus 1. So why is it n minus 1? You may not, you will not look at into this course, but you will definitely look this into stats too when you go to. So there is some reason why we take S square as in the S square in the denominator n-1. So there are few terms that is not done in stats 1, but when you go to stats 2, you look at those terms and then this sample variance again comes into the picture. So that will give you a better idea. But just for this subject, you should know, like when you're finding the variance for a population, this is how you do it. And when you are looking at a sample, and if you have to find the variance of a sample, you do this. Okay. So again, there are some properties, not the properties, I mean, whatever we saw before, like how is the variance going to get affected when you add a constant or you multiply a constant. So let's say my data set was xi, where I is varying from 1 to n. Okay. Now this has been converted to xi plus c. So how will what will be the variance of xi plus c?
Same, ma'am.
Same. Why is that?
Because xi
Hmm?
some c and the
Ma'am, because it doesn't change the
C
variability.
gets cancelled inside, ma'am, so it doesn't make a difference.
Yeah, it
For
doesn't.
mu, you have so many C's, and for that you have that C gets C minus C over.
Yeah.
New variance is equals to old variance.
Yeah. So it will be same as variance of xi. And what happens when xi is changed to c times xi? So what will happen to variance of c of xi?
C square, you get C square.
Yeah, it will be
C
c
square
square
variance.
of x. So you can look at the proof, maybe if you can try it out.
Ma'am, it is C square variance xi.
No, I mean, this is also okay. Fine. I mean, this is not how I should write, because xi I have used to represent each of these data sets. So let's write it as new variance, or maybe the variable is variance of cx. Then I can write variance of c square times variance of x.
excuse me, ma'am, c square just a constant number.
Yes, it is just a constant.
And
Yeah.
in this class, we are complete all theory even
Um,
class.
yeah, that is the goal. Like today we'll complete all the theory. Next class we'll solve some problems.
Okay, then we are next topic.
Ma'am, this variance, what we are talking about, can be found in the ungrouped and grouped both, right?
What?
I mean to say that if we have ungrouped data, we can find the variance.
Yes. Yes,
And for,
in both the cases you can do.
ma'am, for the continuous also.
For the continuous also, okay. Okay, continuous, unless and until you know the values. I mean, how will you? Because to find the variance, you need to know the values.
Each and every value.
Each and every values, and then you need to subtract the mean, right, to each of these, and then do it. So do not go for the group data all the time. Just understand what exactly you have, how exactly do you have to find.
Okay, ma'am, got it.
Okay, then you have standard deviation.
Standard deviation.
So standard deviation is nothing but the square root of variance. So you just find the variance and take the square root. This will give you the variance of x. And so whatever, like adding a constant, multiplying a constant. So adding a constant is not going to change the standard deviation, but multiplying a constant is going to change the standard deviation by c times. So c times standard deviation of x it will become. So in variance, because it is just under root, right? So when it was c square, if you take the square root, it just becomes a c, right? So the new standard deviation will be c times standard deviation of x. Now let's go to the percentile. So this is the last topic that we are looking into. We're also reached 10 o'clock. Okay. So the last topic is percentile. What do you understand by percentile? Have you heard the percentile before?
Ma'am,
99 points divide a data set into 100 equal parts. Let's example, if you got 90 percentile, it means you are better than the 90% of the student, and you are below the 10% of the student.
Yeah. So if I'm saying you are at 90th percentile, it means 10% of the students are scored more than what you have scored, and 90% have scored less than what you have scored. So this is, I mean, you generally see these percentiles a lot in this results of all these competitive exams, right?
Right.
Okay.
Ma'am, is interquartile range and percentile something are the same?
No, it is not the same. So we'll see. So interquartile range, I will also write interquartile range. So interquartile range is Q3 minus Q1, and this is 75th percentile.
Minus 25th percentile of the first quartile.
Yeah. Minus 25th percentile. So, okay. So when we say, as we said, when we say, let's say 90 percentile, 90th percentile. So it means 90% of the people have scored greater than, have scored less than you, and 10% of the people have scored more than you, right? This is how it goes. So when we write the percentile, we say 100p percentile means what? This means this will have the property that at least 100p percent of the data are less than equal to this. So are less than equal to it, and 100 times 1 minus p percent will be more than this, right? So for example, let's say my p is, I take it to be 0.1. Okay. So when I say p is 0.1, it means I'm talking about 10th percentile, right? So what does it mean? It means that 10% of the data are, what have I written here? I skipped right. So 10% of the data will be, so let's say this is the 10th percentile. So 10% of the data will be less than this, and 100 times 1 minus 0.1, which is 0.9. So 90%. 90% will be more than this. right?
Can you
So,
explain one upon time?
sorry,
So basically, if the highest mark is only 60 out of 100,
Hmm.
so everything is calculated based on 60, not 100, right?
Yeah.
Okay.
Hmm.
Can you explain once upon time?
Yeah. So, okay. Let's see what is 100p percentile is. Okay. So when we say 100p percentile, it means that at least 100p% of the data will be less than or equal to this 100p percentile, and 100 times 1 minus p% of the data will be more than 100p percentile. For example, I'm saying let's take p to be 0.1. So when p is 0.1, it means I'm talking about 10th percentile, right? So when I'm saying, let's say you are at 10th percentile. So what does it mean is, like, 10% of the people have scored less than or equal to what you have scored, and 90% of the people have scored more than or equal to what you have scored.
So P varies from 0 to 1.
P varies from 0 to 1.
Okay.
Yeah. Okay. So you have, okay. So we looked at interquartile range, right? So it is Q3 minus Q1. So you have Q1, which is 25th percentile. And how will you get 25th percentile? It means your P should be 0.25.
Right.
Yeah.
So this is, P should be 0.25. Then you have Q2, which you call as 50th percentile. Right? And here, this is also median, right?
Yes.
And here P is 0.5. Then Q3 is 75th percentile.
Third quartile.
This is third quartile, yeah. So this is also called the first quartile. And this is also called the third quartile. Now the question is, how do you find these percentile? Right? So the steps to follow is, the first thing, you arrange the data. In increasing order. Then the second thing is, you have to find NP. And what is N? N is number of observations, okay? So you find NP, then you will have two cases. Either NP belongs to Z, so Z is the notation for integer, or NP does not belongs to Z. Okay. So if NP belongs to Z, I mean, if NP, you find NP, and if NP is an integer, then you take average of values which are in the position NP and NP plus 1. You take the average of it. And in case NP is not an integer, you find the smallest integer that is greater than NP. So let's say I get NP to be 2.5. Okay. So since this is not an integer, what I will do is I will take NP to be 3. I will go whatever the first highest integer comes out to be. Okay. So the first highest that comes out to be is 3. Right? So in the data set, whatever is going to be the third observation, I will go and say this is my whatever percentile you are interested in. Okay. For example, let's see. You have the data set 35. So this is the example that is given in the lecture also. So you have 35, 38, 47, 58, 61, 66, 68, 68, 70, 79. So can you find Q1, the first quartile?
Yes, ma'am. 10 into 0.25.
10 into 0.25. And what is this?
2.5.
2.5 means third.
So I will
Third.
approximate it third. So I will go to third observation. I
47.
will say my first quartile is 47.
47.
What is Q2?
So
Middle
2 will
value.
be 10 into 0.5 means 5.
It's a middle value.
It's the
Middle.
middlemost value, right? So you have, you take the average of these two basically. Yeah, that is just a
Yes, ma'am.
median, right? So it is just 10 into 0.5, which is fifth value. So you go ahead and you take the average of the fifth and the sixth value. So you get 61 plus 66 by 2. What happened to Q3? What is Q3?
Ma'am, but if we go to
0.75 multiply by 2.
ma'am,
Yeah.
ma'am, if we
8
go
observation.
if we go by the percentile, it is the fifth value, then it should be the 61, right? But if we found the median, then 61 plus 62 is there. So
No. What did we say? If NP belongs to Z, you take the average of the values which are at NP and NP plus 1th observation. So my NP comes out to be Z, which is 5.
yeah.
So I will take the average of the values that are there at 5th and the 6th position.
Okay, ma'am, got it.
Yeah. Okay. So now what is interquartile range in this case?
Q3 minus Q1.
Q3 minus Q1, that is 68 minus 47, which is
91.
yeah. So this is how you solve for percentile and you find the interquartile range and everything.
Ma'am, just one thing. Ma'am, for example, if we found that 0.6, so it should be 6, right? So 6 plus 7 divided by 2, like this.
What?
For example, if we found that 0.6.
What is 0.6?
Percentile.
Okay.
Percentile. So it multiplied by 10, so it becomes 6, right? Sixth.
You're taking n to be 10 only.
Yeah. That's the same data set.
And your P is?
0.6.
P 0.6. Okay.
So it should be 6.
It should be 6th.
So according to what you have just said, so 6 plus 7 divided by 2, right?
No. 6th observation.
Yeah. 6th observation plus 7th observation.
Plus 7th observation divided by 2.
Okay. So if it is in continuous form, it means that point form. So it will be the greatest integer. But
Yeah,
if it is in if it is in proper integer, then will be divided by 2. Okay,
yes,
got it.
Yes.
Thank you, ma'am.
Yeah.
Madam?
Yes.
Madam, I want to know that what is the, the way we say that the mean is the central value, it more of represents the other values. But what about this interquartile range like 21? What is the relevance of this value in this data set?
No. So interquartile range is a measure of dispersion. It is not a central value. It is kind of like give a picture of how much your data set is spread out. So same as like you see, range is also a measure of variation, measures of dispersion. Variance is also a measure of dispersion. So all of these are measures of dispersion. It just it gives you an idea of like how much spread is there in the data set. So, okay, I think week 4, you will look at box plot and so on, right? So there you will look at this more properly, this interquartile range, or you will see a 5-number summary.
Box plot is there in this week only.
It is there in this week only.
Ma'am, I have also doubt in a box plot tutorial video.
Okay, okay. Well, box plot is in this week. Okay, let's do one thing. That's already 10:10. So box plot, right? Let's take it in the next session. Okay. I have left
Thank
the
you, ma'am.
right. Yeah, it is in tutorial. So let's take it in the next session.
Thank
I'll
you, ma'am.
stop
Okay,
over
ma'am.
here. Yeah. Okay.
Thank you, ma'am.
Ma'am, I
Thank you,
have
ma'am. Thanks
doubt
a
in
lot.
box plot tutorial.
Yeah. I will take it in the next class.
And one thing is remaining the outliers
Outliers I have discussed. No, outliers I discussed in between.
in a interquartile range. What is the formulas?
Same thing. I will take it in the next session. Okay, because
Yeah.
all this comes at once.
Okay.
Okay, thank you, ma'am.
Thank you, ma'am. Thanks a lot, ma'am. Thanks
Thank
a
you
lot.
all. Yeah. Bye.
Good night, ma'am.
Good night, all.
Thank you. Ma'am.